I've waited a long time to ask someone this question, and it's a very broad question. And the question is, where do you believe that we came from? Where do you believe that life came from? Where do you believe this universe came from?
Well, the universe came from the Big Bang. The question is, where did the Big Bang come from, right?
Okay, so what is the Big Bang?
A Big Bang is a cosmic explosion that took place around 14 or so billion years ago that created the expanding universe.
How do we know that happened?
Because we have evidence of this expansion that took place 14 or so billion years ago. We see the stars moving away from us. So think of a big balloon with points of light on the balloon, and the balloon is expanding, and the stars are moving away from each other. Mm-hmm. That's what we see today. Not moving toward each other. All the stars are moving away from each other like the sphere is expanding. And so we believe in the Big Bang theory, and we believe that the universe is expanding rather than contracting.
Expanding into what?
Hyperspace.
What's that?
Well, we live in a four-dimensional universe, 3 dimensions of space, 1 dimension of time. We live in a four-dimensional universe. But in string theory, we believe that there are 11 dimensions altogether.
String theory is something that you came up with?
I came up with string field theory, which is one of the branches of string theory, right?
And what is string theory?
String theory says that what is a proton, what is an electron? They're nothing but vibrations of a string. So from a distance, this looks like a point particle. From a distance, this is an electron. But if you could magnify that, we find out it's not really a point at all. It's really a vibrating string. And each vibration corresponds to a note. So this would be a proton. This would be an electron. This would be a neutron. This would be a neutrino. That's why we have so many subatomic particles.
Okay, so to simplify this in a way that I understand, you're saying that at the very base layer, particles are the same, but they're just strings that are basically vibrating differently.
That's right.
And that would be the sort of foundational matter of everything.
That's right. Everything is basically a vibrating string. So when the string vibrates in this direction, we call it an electron. If it vibrates in this way, we call it a proton. So why do we have so many subatomic particles? How many of them are there? Hundreds. We've seen hundreds of subatomic particles. And how could Mother Nature be so malicious to create a universe at the fundamental level based on hundreds of different kinds of strings vibrating in different directions? Well, it's really just one string. One string that can vibrate in different modes. Each mode is called a particle.
Why does it need to be a string?
We don't know why things are. I'm a physicist. We just try to figure out the way things really are. But it will explain why there's so many particles. We used to think there was an electron, a proton, and a neutron, and that's it. That's it, period. Nope. We've seen pi mesons, we've seen lambda particles, omega particles, hundreds of subatomic particles. Why do we build atom smashers? Outside Chicago, outside Geneva, huge, gigantic atom smashers smashing atoms apart. Why? Because then from the debris, we begin to figure out these vibrations are particles. We can categorize them. We can give them names. And that gives us a theory of everything. So we have what is called the Standard Model, which explains all the subatomic particles other than gravity. And we create these particles with their atom smashers.
Which is the big machines where they fire atoms at each other in Geneva and so on around the world.
That's right.
To figure out.
That's the Large Hadron Collider, right. But now we realize that there's another octave. There's another layer even beyond what we see with the Large Hadron Collider. Dark matter. Dark matter is invisible matter that surrounds the Milky Way galaxy, and we don't know what it is. There's a Nobel Prize waiting for somebody who could figure out what dark matter is. It's invisible matter that surrounds the entire Milky Way galaxy. We think, though we cannot yet prove, that it's nothing but the next octave.
What do you mean by octave?
Vibration. In other words, this would be the lowest vibration, which corresponds to an electron, but there are other vibrations much bigger, and they would correspond to a higher octave.
How do we know it's there if it's invisible?
Well, this is a guess. But it turns out that when you do the math, and you look at the vibration of a string, and you look at the higher vibrations, some of them are invisible. In other words, they don't interact with light. Now, we know that this interacts with light, therefore we can see it.
The table.
But these are the lowest vibrations. Some of the higher vibrations are invisible. And so we think that's what dark matter is.
I guess this all comes back to the question we were talking about the Big Bang. You know, scientists tend to agree that there was some kind of Big Bang because when you look at the universe, it's expanding outwards. So one would, if you rewind time, at some point there was a central point where something, where an explosion occurred. If you reverse time, it begs the question: what caused the Big Bang?
Well, we don't know, but there are theories. String theory is a theory even before the Big Bang. It's a theory of everything. The Big Bang, in some sense, is a misnomer because it disguises the fact that we're ignorant. We're ignorant of what caused the thing to bang. String theory, there was no bang. That is, it did collapse, if you go backwards in time. It did collapse with a very small thing and then came out again. It bounced.
Oh, okay.
So we think that there could be a bubble bath of universes.
What do you mean by a bubble bath of universes?
Our universe is a bubble of some sort, and the bubble is expanding, and that's called the Big Bang Theory, which fits all the data. But we think there are other bubbles out there. In other words, string theory says that we live not just in a 4-dimensional world, but in a 11-dimensional world. These other dimensions we cannot see. But we think that the universe coexists with other universes. There's a bubble bath. Think of bubbles, soap bubbles floating in the vacuum.
What about marbles? So when you're talking about bubbles, you know, do you mean like kind of like this?
Right. Okay. Give me the big one.
All of them.
All right. Okay. So let's say this is the sun.
Yeah.
And these are planets, asteroids, whatever, and they're going around the sun.
Mm-hmm.
Why? Why are they going around the sun like that? Okay? It's because this exerts gravitational force that is pulling these things toward the sun. Mm. The Earth is just one. Asteroids are none of the other. Saturn, Jupiter, they're nothing but planets going around the mother star. And so then the next question is why? Why is it that planets are going around the sun? It's because the sun is warping the space around it. It's creating a shallow depression. Space is not flat. This is Einstein's achievement. You go in this direction, seems flat. You go in this direction, everything seems to be flat, right? But no, the Earth, for example, is round, but it looks flat, but it's not. The universe looks flat, but it's not. It's curved. And that's why planets go around the mother star, because gravity is a byproduct of the warping of space, and that's why we are sitting on this chair right now. Why are we here? How come we're not flying in outer space? The Earth is spinning, right? Mm-hmm. If the Earth is spinning, we should be flung out into outer space. So how come we're here?
Gravity.
But what is gravity, though? That's just a word,
Isn't
right?
it just because the mass of the Earth is so much greater than us that it pulls us in?
Okay, well, why is it pulling us in? Einstein says that the reason why the Earth is pulling us in is because the Earth warps the space around us and is pushing us into the floor. That's why the solar system works the way it does, because the sun grabs the planets and forces the planets to move in a curved line because it's curved space that is causing it to move this way.
And going back to what you were saying about the bubble bath idea.
Right. Then the question is, are there other stars? Yes. Are there other galaxies? There are billions and billions of planets out there. We think that the whole shebang is curved. We're nothing but inhabitants on the skin of this gigantic bubble. Now we're saying that maybe there are other bubbles out there. A multiverse of universes, parallel universes. In fact, word multiverse has gotten into the literature. Comic books now refer to the multiverse, Spider-Man and things like that. So it's even part of the vernacular, the common language of the average person, that we believe in parallel universes. So yeah, these parallel universes come from physics.
And the other thing that comes from physics is black holes.
That's right. If this star becomes so massive that its gravity is so great that it pulls the entire shebang in like this, and then that would be a black hole. And we now believe that at the center of almost every galaxy we see, and there are trillions of galaxies, we think that at the center of these galaxies, there's a black hole.
Even our galaxy, the Milky Way.
Even our galaxy, right? If you look in the direction of Sagittarius, the constellation Sagittarius, there's a black hole there. So tonight, go outside, look for the constellation Sagittarius, and there's a black hole at the center of our own backyard that holds the Milky Way galaxy together.
So how did it get there?
Well, we think that it's a remnant of the Big Bang, that when the Big Bang exploded, clusters of matter begin to contract other clusters of matter, and this is where the galaxies and the planets come from. The condensation of the matter ejected out of the Big Bang gives you the galaxies, the solar systems, and the planets.
So if I use this as an example, there was the Big Bang and all the pieces flew everywhere. And then because of gravity, the pieces came together and they got so big, so much mass that they collapsed inwards.
We're not sure about exactly which came first, the galaxy came first or the black hole came first. But let's assume for the moment that the black hole came first. Gas concentrated into a small area called the black hole, and then it drew all the other stars and galaxy around it to create the Milky Way galaxy. We're not sure, but that's one possibility of where it came from. And where did that come from? That in turn came from the explosion that created the universe roughly 14 billion years ago.
Am I right in thinking black holes, they are extremely dense, like areas of matter, and if you were to go near one, everything that goes near it gets sucked in?
That's right, and you never get out again. If this is a black hole, there is a ring or a sphere surrounding it, a point of no return. You go toward the black hole and you pass this ring, and then you go into the black hole, never to be seen again. It's a point of no return.
How do we know that?
Well, we've never seen it happen, but we can calculate the escape velocity. In other words, if you want to leave the Earth, how fast do you have to move to leave the Earth? 7 miles per second. Our astronauts travel 7 miles per second to reach the moon. Okay? That's called escape velocity. So every gravitating piece of matter has an escape velocity. For the Earth, it's 7 miles per second. What about the escape velocity of a black hole? It's the speed of light. That's why if you fall through the event horizon of a black hole, you never come out. Because otherwise you would have to go faster than the speed of light, which is not possible. So you go in, but you never come out. That's why it's called black holes.
What's in there?
If you knew, you'd win a Nobel Prize.
This area has loads and loads of mass inside it. It's sucking things into it. So one would assume that there was a lot inside there, but it's tiny, right? Black holes are tiny?
We don't know how big they are. We think at the very center, it could be very small. We're not sure. No one's ever been there because if you go past the event horizon, you never come out again.
What do people think is inside a black hole? Because I'm thinking of it's just this area in space that looks black when you look at it, and it can suck in planets, anything.
If I were to take a guess, I would say that it's an entrance. It's a gateway, perhaps to another universe. We think, for example, if I have a warp space and you fall into warp space, if the warp space is powerful enough, it may come out again on the other side. Mm-hmm. So there may be another universe on the other side of a black hole. We're not sure, of course. If you want to go to Alpha Centauri with a Saturn V rocket, it would take 70,000 years to reach the nearest star with our most powerful rocket. Very impractical. You need a shortcut, and that's the gateway called a wormhole, which is very similar to a black hole. A little bit different, but very similar.
How long have you been studying physics in the universe now?
Since I was 8 years old, I've been studying the universe.
71 years.
Yeah, when I was 8 years old, a great scientist had just died. It was in all the newspapers, and the newspaper said that he failed on his last try to create a theory of everything. So I was fascinated by this idea that this man was attempting to find the final theory.
You're talking about Einstein.
That's right. Later, I found out the man's name was Albert Einstein. And at that point, I said to myself, that's for me. That's what I want to work on. I want to be part of this great journey to complete Einstein's dream of a theory of everything. And that's what I do for a living. I work with Einstein's equations.
So for 71 years, you've been trying to understand the universe and create this theory for everything. In that time, how is your perspective on God developed?
Yes. Most of my family were Buddhists coming from Japan. But my father was a Christian and put me in Sunday school. So I had the benefit of two religions as a child. Now I'm a physicist. And physicists are, quote, agnostic. They don't take a position. They simply go where the physics takes them, into areas that are distasteful, mysterious, whatever. You go where the evidence goes. And that's what I am today. In other words, we have the laws of physics. We have string theory, which takes us to the instant of the Big Bang, and even before the creation of the universe. But then the next question is, where does string theory come from? Okay? At that point, we have to say that that's where our ignorance takes over. We simply don't know.
What about simulation theory? Do you think it's plausible that, in fact, we are living in a simulation?
I would say the answer is probably no.
Probably no.
That's right. Simulation theory is basically saying that the universe is a puppet show and there's a script. We're living out the script because somebody is pulling our strings. First of all, that violates quantum theory. Quantum theory believes in probabilities. Probabilities that I'm sitting here today, probabilities that maybe one day I'll go into outer space. We can calculate the probabilities of atomic events, chemical events, with accuracy that is incredible. But simulation theory is not one of them.
The theory, which was proposed by philosopher Nick Bostrom, says that there's three possibilities logically. Either number one, that human-like civilizations always destroy themselves before they get to the point where they can do advanced hyper-realistic simulations. And if you think about things like, I know, virtual reality at the moment or video games, and you imagine them on a spectrum, if they just get 1% better a year, at some point they are indistinguishable from this reality that we're experiencing now. So theory one, we wipe ourselves out before we get to the point where we're advanced enough in hyper-realistic simulations. Theory number two, or possibility number two, is that advanced civilizations do exist, but they have zero interest in simulating their ancestors, which would be us. Or theory number three is that we are a simulation and civilizations do survive and they do run millions of simulations because there would be millions of fake universes and only one can be base reality in this scenario. And the mathematical odds are incredibly high that we are currently living inside one of those simulations and not in base reality.
Well, my personal point of view is there's option 4 that you don't mention. And option 4 is that there is no simulation at all. That all this talk is nothing but fairy tales that we tell our children to amaze them about the universe. But you see, the universe is based on probabilities. Probabilities that uranium will fire, for example, which gives us nuclear weapons. Probability that hydrogen can fuse, and that gives us stars. So the universe is based on probabilities, not on simulations.
If you love the Diary of a CEO brand and you watch this channel, please do me a huge favor. Become part of the 15% of the viewers on this channel that have hit the subscribe button. It helps us tremendously, and the bigger the channel gets, the bigger the guests.